We're going to find the interval of convergence for the following power series. And the way we do that is we start off with the ratio test, the limit as n goes to infinity, of a sub n plus 1 over a sub n, or basically a sub n plus 1 times the reciprocal of a sub n. So we have the limit as n goes to infinity of the absolute value of negative 1 to the n plus 1, x minus 2 to the n plus 1, over 5 to the n plus 1 times the reciprocal of the original, so 5 to the n, over negative 1 to the n, x minus 2 to the n. Now we'll rewrite and see what kind of canceling we can do. So we have a limit as n goes to infinity. Now because we're doing the absolute value, this is going to come out to be negative 1, because we're going to cancel n of them out with n plus 1 here, so we end up with negative 1 to the 1, which is negative 1. But because of the absolute value, it's going to be positive anyways. So a lot of times with the ratio test, if you don't even want to write that alternating piece in here, that's fine. It's not going to affect anything. Here's the parts that are going to be the deciding factors. This can be rewritten as x minus 2 to the n times x minus 2, because we have n plus 1 of them. Similarly, we can write this as 5 to the n times 5. And let's just extend our bar there instead of writing a whole other fraction. And x minus 2 to the n. And all those are products. And it makes our canceling very clear. Now at this point, what I like to do is, this no longer depends on n, so I'm going to pull it out front, but it does end up in an absolute value. And then times the limit as n goes to infinity of all we have left is 1/5. And the limit of a constant is just itself. So this equals 1/5 times the absolute value of x minus 2. And our goal is to have this to be less than 1. Well, we can multiply both sides by 5. And what that gives us is the absolute value of x minus 2 is less than 5. So right there we do have our radius of convergence, but we're going all the way for the interval of convergence. Well, we can do this very quickly by saying, okay, well, if the absolute value of x minus 2 has to be less than 5, that translates into x minus 2 must be less than 5, but also greater than negative 5. Negative 4, for instance, the absolute value is less than 5. So we're going to add 2 to each of these. And that gives us that x has to sit in between 7 and negative 3. So there's our endpoints. And we're in really good shape. The only thing we have to decide is, should we include our endpoints? So we must check our endpoints. So that's an extra couple steps over just doing the radius of convergence. So first thing we'll check is x equals minus 3. And what we do is we plug that into our original series for right here. So what would that look like? Summation n equals 0 to infinity, negative 1 to the n, 3 minus 2 to the n, over 5 to the n. So all I did was plug, negative 3 in to my series. So let's see what happens. If I do that, I need to simplify. I've got n equals 0 to infinity of, lost my n there, negative 1 to the n, and I'm going to end up with negative 5 to the n all over 5 to the n. Well, these are both to the n, and actually all three of these pieces are, so if we want to, we can put them all to the same exponent. And we're going to see real quickly what happens. So we'll have negative 1 times negative 5 over 5 to the n. And multiplying this all out, we just get 1 to the n, which is 1. The summation of 1 does not converge because it's the limit We also need to check x equals 7. And we plug that into our original, and we can see 7 minus 2 is going to give us 5. 5 to the n over 5 to the n is going to cancel. So when we plug in that 7, we're going to get 0 to infinity of just negative 1 to the n. This also is divergent. And we could use the exact same test. Limit as n goes to infinity of negative 1 to the n does not go to 0. So we do not want to include either of our endpoints, and there is our interval of convergence, or if you wanted an interval notation, -3 to 7.